Right. We just talked about the periodic table, and so we're on page 4 of the notes. We started page 4, and this chart I got from online. I actually really like this chart. I recommend that. So we will have a midterm. I called it a celebration, but that's not until like the 4th week or something. You're going to want everything organized nicely. And one of the things, and also for your study set and your worksheet for next Tuesday, oh, that was the comment I was going to make, is I usually open the next week's folder Thursday or Friday. So if I forget, which happens, just send me an email and say, hey, when are you planning to open the next week folder? So I have it all there. I just usually wait until after class on Thursday so that students don't get mixed up and start doing the wrong homework or panicking. So this, though, you're going to be using. So maybe making a note card or cutting this out and putting it in a nice place or flagging it so you can find it. I wanted to go through these examples here and finish this page and the next pages. So we're going to be doing a lot of math, and that is what your next study set is math, and what we're going to be getting into then in the next lesson. So those of you who took Chem 151 or Chem 104, this should be review, because you should have learned how to do this factor label. And Omar's going, oh boy, he came just in time to do his favorite. Is we're going to do moles next week. Yeah, he's like giving me the thumbs up. He's just like, all right, bring it on. I got it. So let's go ahead and do this one, the 22.5 millimeters. And again, there are other ways you can do it, but we're learning a specific method of doing math, and you're going to be doing your exams are going to be pretty much show your work, and you're going to be required to use this method. And so that's what your next study set and worksheet are about. And I just realized, yeah. All right. So I recommend that you always go through the base unit, and so change in the factor label. You take this unit, you bring it down here, we go to meters, and then we're going to change meters, and this is actually angstroms. And this is a unit that is only used by chemists and possibly physicists who are particle physicists. Usually the A has a little halo on it, like the Angels, like baseball hat. I don't know, or maybe I made that up. That I was like, put the halo there. And so I didn't realize I had that as the next question when I stopped. What an angstrom is it's 10 to the negative 10th meters. And what it is this is the size of an atom, roughly. Atoms are somewhere between 3 and 5 angstroms in radius. So it's a unit of measurement that's used by chemists. I don't know if we'll run into it again, but in case you do, we might, because there was a homework problem I used to have. All right, how the chart works is, again, you always have 1 with the prefix, so 1 millimeter, and then this number up here, the 10 to the negative 3, goes with the base unit, which would be the meters. And then we would punch that in our calculator, we'd get 7/8. So 2.25 times 10 to the 8th. It just takes practice, and that's what your study set. 1 page is about Sig Figs, and we'll talk about that in a minute, and 1 page is doing some of these math that we're going to be doing tonight. And then the worksheet is a little bit more challenging, because the only way you're going to become proficient and good at this is to keep doing more and more problems and more challenging ones. Something I wanted to mention, because it happens in here, is scientific notation, and Tinkerbell does talk about it, making sure you use correct scientific notation, which means where you have the decimal, there is always only 1 digit to the left of the decimal. So you cannot say 22.5 times 10 to the 7th. Although that is the same number as this is incorrect notation, because there's 2 digits to the left of the decimal. And when I say digits, I mean non-zero digits. So you have to have a 1, 2, 3, 4, 5, 6, 7, 8, or 9. All right. Let's do this one. 0.15 deciliters. And I'm going to always do it going through the base unit. What I've seen is some students, like last term, those who were with me in 151, your first lab actually had you doing a whole bunch of conversions. And the students who did it this way, they all got it. And the students who decided they were going to take shortcuts, they like got them all wrong. So it really, as you get to do factory label and become proficient, it's actually very fast and very effective. The ones go with the prefix. So deci and pico get the ones. And so deci means 10 to negative 1, and pico means 10 to negative 12. There is other ways to do these, but what I'm just trying to focus on right now is how this chart works. Because if you're somebody who's already good at metric, then keep doing it the way you do it if you're really good at it. If you're somebody who's always struggled with it, do it this way. It ends up being a game changer. So if you punch that, well, I'm not gonna, if you punch it in my brain right now, I get 0.15 times 10 to the 11th. But then I had to move my decimal 1 over, so it's gonna be 10 to the 10th. So 1.5 times 10 to the 10th. And this is, you can either show it with the parentheses or you can show it with this. And again, if this first box here is blank at the bottom, it's like most of the time blank. If you don't like the blank, the nothingness, which remember 99.99999% of you is nothingness, possibly even more. You can draw whatever you like, a unicorn, a Christmas tree. I don't even know what is January, a snowflake. All right. We're going to now use other conversion factors besides just metric ones. US conversions, common ones. If we do some weird ones, I will give you a conversion. I often like to write up questions where I give you like gnomes, me and the gnomes have a chat and they tell me their conversions. But some of the US ones, because several of you are from other countries, these are actually called imperial units, and they're kind of obsolete. There are 12 inches in a foot. I'm pretty sure you all know that. There's 3 feet in a yard, and there's 5,280 feet in 1 mile. So the abbreviation for a mile is MI. It is not just M, because just M means meters. Another one is there are 16 ounces is 1 pound. We used that one the other day. The 2,000 pounds to a ton is pretty much, nobody uses that anymore because we've all moved to the metric. So I'll even put that one in. And the thing that's really good news is next week, once we get to the periodic table math, we pretty much stay in the metric unit because the periodic table is in metric. I'm trying to think what my other ones are. Oh, 4 quarts to a gallon. So it can be handy to make like a little note card or a piece of paper, like for your celebrate or for doing anything, just having this all in one handy dandy place. Right, so 4 quarts to a gallon, and there's 2 pints to 1 quart. And then one other one that I use is 32 fluid ounces is 1 quart. So my box didn't work out right. A mass ounce, this is a mass ounce and this is a fluid ounce. They are not the same thing except for water. So water is the only time they are actually the same. All right, Sig Figs. Yeah, so this whole page is about the Sig Fig rules. And in the fall, so as you're with me, Chem 151, so Spencer, I wanted to tell you something. I tried to respond to your email today and it kicked it right back to me and said you no longer existed. And so you might want to try sending me an email again and let me see if that happens, because I've never seen that happen for a student. And so I don't know if it was just like a weird quirk of electrons at that moment in time. But do watch this video because we do work with Sig Figs. I'm actually really happy that I got to make this video because Sig Figs are really tedious and it's always kind of a downer for me to have to spend time going through them. So that's why I dressed up like Tinkerbell and went through them. Your study set for Tuesday has actually a whole page about Sig Figs, and so we'll go over it when we do that. The thing I do want to talk about, and I don't remember if Tinkerbell did because that was like last year, is the difference between exact and inexact numbers. Exact numbers are exact. They have infinite Sig Figs. It means we don't look at Sig Figs. Inexact means Sig Figs. And as we do the math on the next few pages, you will see what I mean. And so for those of you from 151, this is really great to listen to perfect your understanding of this so you can cruise through everything. And those of you who are new to it, you will get it. It's just going to take some time. And so, yeah, I've done this for long enough and with enough students that you can do it. Every single one of you can do it. It's just taking the time to do it. An advantage we have with Thursday class is you then have a nice weekend before your next one's due. And so just make sure you take the time to work on this. All right. So inexact is if you have a measurement, and a measurement is what we just did on this page. So liters, meters, grams. So mass, distance, temperature is a measurement. So if you say, hey, what's the temperature out? And I tell you, well, today was beautiful here. It was 56 degrees Fahrenheit. That is a measurement. So I'm only giving you 2 Sig Figs. All right, the other thing that is limited Sig Figs is when we do a conversion between different types of units, like US to metric, those are inexact because the US system is imperial and was based on the king, like a foot was the size of the king's foot. The metric system was based on science, and so going between them is always an approximation. The same with if we went like between US and gnome measurements. The gnomes have a far superior way of measuring, and so that's always going to be an approximation trying to go between them. So inexact just means we're doing an approximate. So the lab, the numbers that I use in the lab, they all have limited Sig Figs. So lab is all about measurements. And so that is why the density lab that you're going to do, like get the measurements that I have, put it in that chart, and then just crunch out a bunch of numbers to get the idea of that. Exact is 2 things. One is if you're counting. So like number of people, so number of gnomes or people or students. So like our class, I actually have no idea. There's 25 participants here, it tells me on Zoom. And so 25 would be an exact number. Even if you're sleeping, even if you walked away from the monitor right now, there are 25 boxes on my Zoom. That would probably be better than saying participants, since some people walk away or take a break or fall asleep. I just can't tell. The other thing that is exact is if you're within metric. So metric to metric, so what we just did on this page, these are exact. So 100 centimeters is 1 meter, or a centimeter is 100th of a meter. That is what is called a definition. So we're defining a centimeter. If you go US to US, so if you're staying 12 inches is 1 foot. That is what a foot and an inch are defined as. And yeah. All right, so that's exact and inexact, and something to keep in mind as we move into the math on the next page. I'm going to move on unless somebody needs me to pause and go over something. All right. Or you can always stay after and ask too. So we got done with 4 pages. You have to watch Tinkerbell. So I efficiently got to page 6. And we talked about unit conversions. We started looking at them, and that's what we're going to do for the next 45 minutes is just more of this math. And so we're going to be using those conversions on the previous page, like 12 inches to a foot. And we did one short one here with the gnome. And so we're going to try these other ones on this page. And then we have another page to do with them. Something that's really helpful, it mentions using colored pens and underlining the information. So in chemistry, this is all about units. We don't have just numbers. Numbers mean nothing by themselves. Numbers have to have a unit with them. And we're solving for meters. So underline all the numbers that are given. In this case, I just gave you one place to start. When we get on the next page, we'll see more complicated ones. And then write where you're going, so meters. And again, you can use the parentheses like I did here, or these boxes are really nice. You can only have 1 unit per box. So I can only have feet here. There's nothing underneath. Again, you can draw whatever symbol you want. You can do a star, you can do a heart, you can draw a snowflake, you can draw a camel. All right. And we're going to go to meters. Oh, so there is a rule. I have to make a rule. I've never had to do this before, but I do here. We have to use these conversions. They, when you do your study set and your worksheet, you're going to be limited. You can go on Google, and Google can convert this in 1 step. By the way, there are not 3 feet in a meter. There's 3.28 feet in a meter. That is not exact, but we're going to use one of these up here just so we practice doing it in multiple steps. So I'm going to actually go feet to inches. And then I know there's 12 inches in a foot. And I cross out my feet. Now I have inches, so I'm going to take this unit and I pull this unit down here. And I'm going to go to centimeters. And I know that I'm limiting us. These are bridges. So we're going on a hike together between feet and meters. And I'm limiting you to one of these 4 bridges. So we don't want to use the first one because that deals with mass. We don't want to use the last one because that deals with volume. So we're going to use one of these in the middle. And so I'm just going to use the centimeter inch one. The kilometer mile is if we're dealing with larger distances, like on the next one, we'll use that one. So this is given to you. And the thing that's really nice with the ones that I gave you up here, they are bridges between US and metric, which means we have to look at Sig Figs. Now, the thing that's really nice about these is all of them have 4 Sig Figs. So there's 4, there's 4, there's 4, there's 4. The one you don't look at, that's just what we're going with. The other thing that's nice that can help me so I can do this more smoothly in my brain is I always made the 1 a US number. So if we were doing the Olympics, which nothing's happening right now, but we always sit there saying USA number 1. So I know my 1 goes with my USA unit, and then my metric unit will get my conversion. Now, I have to make a quick comment about centimeters and inches. Somebody declared about 10 years ago that this was exact. It's not, but somebody's declared it. So if you go online, you might see places where they say this is an exact conversion. I'm aware of that. I just have trouble with some random person deciding that, even though they're not. It's like 2.54005. Which could make quite a difference when you're dealing in the scale of chemistry, where we're working with such teeny tiny dimensions that would actually make a difference. All right, I can change centimeters to meters because that is metric. All right, You can do 100 centimeters to a meter, or if we're going to use the chart from the previous page, centi is 10 to the negative 2. So this is saying that these are always something that can help. I had a student last term, and if you put a 1 in front of each of these up here, this is equal, 1 nano is equal to 10 to the negative 9, or 1 centi is equal to 10 to the negative 2. That might help you. So 1 centi is 10 to the negative 2. So my inch canceled, my centimeters canceled, and I'm left with meters. And we would punch that in, and that's my calculator again. I love my organization skills. There we go. All right. So punching it in, right, 1.55 times 12 times 2.54 times 10 to the negative 2. All right, so your calculator gives you all these digits. So we have to talk about Sig Figs. This is exact, because we're going between metric and metric, and this is exact, 12 inches to a foot. This one that's given has 4. If you want to say it's exact, that's fine. I don't care, because it turns out the original number limits us. The numbers that I give you in these problems are measurements, and they always limit your Sig Figs. So something that a lot of students will talk about, or to think about this, is the numbers that I give you are the ones that are going to determine your Sig Figs, meaning these US to metric conversions and the numbers within the problem. And so it's the one with the least number of Sig Figs, which is going to be the 3. So we go back on our calculator and we get 0.472 meters. And here we go. All right, you do not need to put this in scientific notation. So scientific notation, same with this one up here when we did the ounces. Scientific notation is used as an efficiency thing. So when you're dealing with lots of zeros, so 10 to the 5th, 10 to the 8th, 10 to the 10th, that would get really confusing to write 1, 5, 0, 0, 0, 0, 0, 0. Like you can't even see, I can't even figure out how far I want. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. That number is really hard to see that way. It's much easier to see this way. Likewise, this would be really weird in scientific notation. So it's usually when you get to about 3 or 4 zeros that you start putting things into scientific notation. The other comment I want to make is this 0 before the decimal. I honestly don't care if you show it. What I care is that I can see the decimal. However, if you're going into nursing school, which I know there's 2 of you in here who are, they will mark you wrong if you don't show the 0 before the decimal. I think that is also true with pharmacy school, and that's because they've killed patients. Make sure people can read your handwriting is really the take-home message from there. All right, so let's do the next one. That's the piece of information about how fast the fairy flutters, and we're going to change it to miles per hour. So this one is a little bit different. And it is that we have 2 units. We have meters and seconds. So per means, and this is where these railroad tracks really rock, is you can only have 1 unit. You can't use a slash in this. You can only have something on top of something else. And so this means we are going this many meters per 1 second. And so what we're solving for are miles per hour. All right, something I said last class, and you'll see it on top of your study set and your worksheet, is you don't break this into steps. You can only have 1 equal sign. And so if you do break it into steps, you're not going to get full credit. Sometimes I don't give you any credit because the point of this is doing this. So we're going to first change it from meters to miles and then seconds to hours within the same flow. So it's going to be 1 flow. It's kind of our motto right now, is we're flowing. And so I'm going to use this conversion of 1.609 kilometers to miles because I want to get to miles. All right, so I'm going to go meters to kilometers. And then I take my kilometers and I change it to miles. Each one of these boxes has to hold true by itself. So you're just looking vertically within that. Does that hold true? We go from this to that to make sure my meters cancel. So kilometer, you can do 1,000 meters to a kilometer or 10 to the third. That's from our metric thing. My meters cancel. And then this, miles is 1 and 1.609. All right, when we're working with 2 units that we're trying to convert 2 units, this is just a suggestion. It's really helpful to circle a unit when you get to it. So when I circle it, it says to me, to myself, me, myself, and I mentally, don't cross that unit out. We're there. I want to be there. I'm not done though, because if you notice, I don't have a heart or a star for this one. I actually have another unit. And how this works, because it's all multiplying and dividing, it does not matter the order of your steps. It does matter that you have the correct number on top or bottom. So seconds is now going to move to the top because it was on the bottom. And I'm going to change seconds to minutes. My seconds will cancel. There's 60 seconds in a minute. And then there's, pull the minutes up to the top, there's 60 minutes in 1 hour. And then I punch that in. Just a real quick side note, the correct abbreviation for seconds is S, but when you write S, you think it's a 5. We all make that same mistake, so I actually recommend you write sec. And for punching it in my calculator, I just go straight across. If my number is on top, right, so my 3.14159, I'm going to divide by the 10 to the third. And I don't use parentheses. You can. I just want to make sure you can all punch it in your calculator. And I'm just mentioning this because some students, it helps them. And we get this huge number, this crazy, it's actually not a big number. And then we have to figure out Sig Figs. So the number I started you with has 6 Sig Figs. This one's exact. You don't have to write this piece that I'm doing for Sig Figs. This is just to help you to visualize it right now. This one has 4 because it's a US metric. And my time conversions are exact. A time measurement, like it takes me 1 hour and 2 seconds to go for a walk around the block. That is a measurement, but time conversion is exact. So we're going to have 4 Sig Figs because that's the least number. So 7.029. All right, let's do it down here. 7.029 miles per hour. That's faster than I can run. I'm pretty slow. A lot of you, I bet, can run faster than the fairy. Questions?
Sorry, why don't you time it by the 60 and the other 60?
Because there's 2 of them.
So
I went
on top.
Huh?
Aren't they both on top so that way they just can't?
Yes.
Okay.
You can also, if you don't like how I do it, you can also, what some students will do is multiply across the top and then divide across the bottom, but you have to make sure you put parentheses then. So, yeah.
Okay, thank you.
Yeah. On the next one, there's actually 2 pieces of information, and the question I want to know is how many grams, and it's how many grams of the fluffernutter. So I don't know if you guys know what fluffernutter is, but it's peanut butter with marshmallows in it. And my birthday is actually National Fluffernutter Day. So you can Google when is National Fluffernutter Day, and then you'll know when to send me a happy birthday message. My birthday is also Hydrogen Day. So those of you who were in my class last term, you remember that. So that should be a bonus. Who can find what element is your, that was a bonus last term.
October 8th.
It is October 8th. And actually, it was really funny because when I found out it's actually International Hydrogen Day. The other chemists feel a little inferior to that because none of their birthdays, but it was, Spencer made a comment that I was reusing my same bonuses from last term. I do start deviating, Spencer, once I get through like the first week. This has been the craziest first week ever. All right, this one has, I want to just write it here. This one has 2 pieces of information. So it's milligrams per kilogram, and then we have 333 pound troll. And so, yeah, Spencer, right now I'm even, this page is completely from last term, but it works for me because it has the gnomes and the fairies and the trolls. A mistake that students do when we start having multiple pieces of information is they just always start with the first piece of information. Don't do that. Like underline all of your information. And my recommendation is start with a piece that has only 1 unit. So we're going to actually start with the 333 pound troll. And the reason for that is we're wanting to end with only 1 piece of information. This is a conversion between milligrams and kilograms. It is only works for this problem. It won't work for any other ones. So you put your heart or snowflake or star or moon. It's a crescent moon out there. We're almost to a crescent moon. And this is a dosage problem. And how dosage problem always works is it's always the dose over the body weight. And so for those who go in nursing school, this is like the key one. You never ever flip the dose upside down. The body weight always stays on the bottom. So we're going to go, just for practice, we're going to change our pounds to grams because that's the conversion I gave you. Because in chemistry, we usually work with small things, not trolls. And then we're going to change our grams to kilograms. So body weight, whether it's a gnome, a person, we always want to talk about it in kilograms when we're doing dosage problems. All right, US gets the 1,453.6. We're using these conversions. So I cross out my pounds, and then kilo is 1,000 grams or 10 to the third. So kilo is large. Always, I'm trying to be consistent again with that chart. All right, and now my dosage comes in here, that 1.618 milligrams to 1 kilogram. And what this is, you can leave it just like that, but it's for every 1 kilogram of the troll, you have this much fluffernutter. So we'll say fluff, which is the fluffernutter. All right, you really shouldn't eat fluffernutter. It really should have been banned. It's probably worse for you than smoking cigarettes. But that's a whole nother topic I could go off on. And we want to go to grams, so milligrams to grams. I've had so many students have trouble with these problems. Dosage problems are hard because we're dealing with all these different masses, but this is how it would look. So milli, and that would be 10 to the negative 3. And to punch it in my calculator, 333 times 453.6 divided by n times, oh, there we go. Is that right? Somebody else get that?
That's what I got.
Great. And 3 Sig Figs, why?
We're limited by the 333 pounds.
Yeah, so the numbers, that number we started with limited us to 3. The dosage also has Sig Figs, but you always go with the least number. And my conversions between US and metric, since you're going to be limited to my 4 conversions, they all have 4 Sig Figs. So if I start you with only 2 or 3, you're going to have 2 or 3. Anyway. All right. Any questions? I know some of you probably are like, whoa, it takes practice. So my students from last term, especially Omar, he would tell you, and yeah. All right. So we got 2 pages to go. And so page 7, I actually also videotaped. So before next Tuesday, you definitely want to watch this. So again, another 30-minute video. I do want to go through this top part because you have a lab due on Saturday that's about density. So you may actually want to watch at least the beginning part of the video. Most of this is factor label, and we're going to do a whole page of factor label practice. But density is mass per volume. So it's how much matter, how tightly the matter is packed together. So mass is a measurement of matter, of substance, and so it's how tightly it's packed together. In chemistry, we tend to use grams per milliliter or grams per cubic centimeter. And this is also where I get a mention. A milliliter and a cubic centimeter, they're the same thing. Yeah. All right. You can have other units of density, and I talk about that in the video. And we use it in all sorts of places. So the two big ones I can think of, like a lot of people like make beer or wine, or maybe harder liquor in their garage, like a moonshiner or something. I grew up in West Virginia originally for my first like 7 years of life. And we did not have a moonshine in our backyard, but we went on a hike the day we were like moving, and we ran into some moonshiners. It's a very vivid memory in a 7-year-old's mind. But another time is like when you're pregnant, the woman always goes to the doctor every month, and the first thing they make you do when you get in there is pee in a cup, and they're actually checking the density of your urine because it's a measurement to see how much protein is in there. A lot of times when they pour concrete, they need certain densities to make sure for the foundation and stuff. But the lab for this week is all about that. One of the things though with the lab is you're going to be doing a lot of subtractions to figure out masses, and then subtractions to figure out volumes. And that's why I'm going to have an office hour on Saturday morning. So if you have questions, to come then. We're going to skip to page 8, which two things going on actually on both of these pages. Whenever you see me like give you these word problems and I put a number here in parentheses, that is the answer I got when I punched it in real quick, typing up the notes. They're almost always right. The key was almost always. There are occasions when I have a number that is incorrect, and we usually find it as we're going through. I'm pretty certain all of them are good because I've used these notes long enough, but it used to be I would be in class and not at my computer where I could change my answer when we found a mistake. So if you're ever working on these and you can't get to my answers that are in parentheses, just make a note to ask me because, or as we go through it. All right. So I'm going to stop recording for 10 minutes. You guys can take like a 5-minute break or something, or you can try 1 or 2 of these. Yeah, or you can ask a question. And I keep getting a weird message every time I look at that. Oh. Okay. So, I think my answer is right. This is my piece of information. So this giraffe, I don't know if Zulu is still alive. Probably, I don't know how long giraffes live. We're using, if you use different conversions, you know, I'll forgive you right now, but on the worksheet, on stuff that I look over in grade, we want to use those conversions that I had up here. So to go from feet to meters, and pull the feet down and change my feet to inches, and then my inches to centimeters, and then my centimeters to meters. And yes, I am aware you can do it in one step, but we're practicing doing it in multiple steps. So next week when we do it the periodic table, you're proficient at this. All right, one of the biggest mistakes is made with the ones that most of you are really familiar with, which is there's 12 inches in a foot. So just make sure that you take a deep breath as you do each one of these. Think of this like this is a mindful meditation. And so as you do each step, just take a nice deep breath and say 12 inches in a foot. US gets the 1, 2.540 centimeters, and then centi gets the 1. Centimeter is 10 to negative 2. And did somebody punch it in and get my number?
Yes.
Great. So I fixed my mistake. I knew that one for like 10 years. I had it wrong and I finally fixed it. All right, on the next one. So the mushroom mobile shows up in a lot of questions. Go with whatever numbers I give you in that question. All right, and we're solving for kilometers per liter. All right, so 600, there's 2 units on this one. So we would do miles per gallon. So only one unit in each dimension, and kilometers per liter. So when you're working with 2 units, one on top and one on the bottom. And again, you can leave that blank. And it is 1 gallon. Some students need to put the 1 there. You don't have to. I know what I was going to say. Do not abbreviate gallon as G. It is not a gram. That will confuse the heck out of me. Everybody else, this is, yeah, you want to make sure you can clearly communicate. So miles to kilometers, we can do that in one step, because that is one of the conversions I do give you, that a mile is 1.609 kilometers. So we're halfway done. But we're not going to figure out miles to kilometers and separately figure out gallons to liters and bring them together. We're doing this all in one flow. An advantage there is you're not approximating and approximating again and approximating again. So you're only approximating one time. Think about it like that. All right. So now we have to pull the gallons to the top. Now, I don't give you gallons to liters. I give you quarts. So we're going to change the gallons to quarts, 4 quarts to 1 gallon. And then the quart to a liter. And quarts are 0.9463 liters. All right, so I think Major, it was you were asking me about punching these in, and so I'll walk through this one. So you would take the 666, again, I ignore ones, and then I multiply because the next number is on top. I divide by the 4, and then because it's on the bottom, and then I divide again by the 0.9463. And 3 Sig Figs, because the number I started with had 3 Sig Figs. So just play with that. That's what this is all. You have the study set and worksheet for Tuesday so that you guys feel comfortable to move to the next step, which is moles, which is one of the essence things of chemistry, which is the math we do at the periodic table. All right, the next one, we have 2 pieces of information. We're trying to figure out minutes. So yeah, so this is our answer. One of the things I will tell you that will really help you to become better at problem solving is to write down the unit you're trying to solve for. So always write that at the end. Now, don't fall into the trap of starting with the first piece of information. So start with the piece that has 1 unit, the 3.14 miles. And that's because we're solving for 1 unit. There's also another reason. If you tried to start with the 536 centimeters per second and tried to solve that for minutes, it's not going to work because your time is in the denominator. And so you would have to flip this. If we start with the miles, it will naturally flip. So that's something to ponder. All right. And so it's like, well, how can I change miles to minutes? We're going to use the other piece of information. So I'm not going to give you extra piece of information. You're going to use all the pieces that I'm going to give you here. All right. And what I know in this piece of information is how many centimeters per second. I have had if students get like really stuck, one of the tricks you can do is always work backwards. So do their minutes to seconds and stuff. It's kind of, anyway. So I'm gonna get my miles to centimeters. So I'm gonna go, there's different ways you can do this, but I'm gonna go miles to kilometers because that one I have up there. 1 mile is 1.609 kilometers. And then kilometers to meters, meters to centimeters. And again, you could have done it also miles to feet, feet to inches, inches to centimeters. They'll come out similar when we round to 3 sig figs. All right, kilo and centi get the 1, and kilometer is 1,000, centimeter is 10 to negative 2. And again, if you're comfortable doing 100 centimeters to meter, do it that way. Just find the way that you're most comfortable with. I really kind of was freaking out in the fall because I have been teaching factory label for 25 years and have been really successful teaching it, but I've always had a visual to help the student, like that I can see the work you're doing. But it did work. All the students did actually phenomenal with it in the fall. So, but what they did, and actually several of the people here will tell you they were amongst them, is they made the time to come to my office hours. And so I'm here the hour before class on Tuesday and the hour after. And so you might want to just start saying, okay, the class is 3 hours, which it would have been in the real time. And even then they would come an hour early. So they all would come, they'd all actually be there like 5 hours and work together. All right, so the centimeter now, I'm going to change to seconds, and that's the step. And the 536 is how many centimeters in a second. But when you have 2 units, you can flip them upside down. It's a conversion that is specific to that problem. And then we would just do 60 seconds to 1 minute, and you'll punch it in and get that. Questions? So that one's a cool one. That's a really nice one. You can follow along. You can copy this. Again, I videotape, so you guys have a huge advantage. All right, this one's awesome because it's all metric. And I have no problem with scientific notation. You could write this out longhand. So it's basically 1.11 million. So nanograms per centiliter, and writing down where we're going, which is milligrams per deciliter. So having done this problem long enough for many years with hundreds, thousands of students, I think I've only had one student who did it in a shortcut way and did it correctly. And so where I've had many, many, many students who did it this way, where you get rid of the prefix nano to gram, and then you go gram and you add the other prefix on. So I recommend if you're doing a metric to another metric, rather than trying to do it in one step of getting rid of the prefix and then adding the prefix on. And so nano, milli get the 1. Nano is 9. It's 10 to the negative 9. You guys have that chart? Just have it. Put it up on the wall in front of your desk. And milli is 10 to the negative 3. All right, so that gets us to the top one. Now we have to do the centi. And so centi to liters, and then liters to deciliter. The centi and the deci get the 1 if you're using the chart. There is, if you're comfortable doing it the old-fashioned way, you can. Centi is 10 to negative 2, and deci is 10 to negative 1. All right, and centi cancels, liters cancel. So we're left with milligrams per deciliter, and there's our answer. And again, I'll be staying after, so if you want to stay and walk through any of these today. And again, that page before is also factory label, and it's walking through it with Tinkerbell. Yeah, and so I recommend actually when you do this page, when you watch that video, that you actually pause Tinkerbell and you try the problem on your own, and then you can watch me doing it at an actual blackboard or a green board. What fun for me. All right, circle all the information, and we're going to start with the gnome's body weight. So the 3.14159 pounds. And we're trying to figure out the grams of UB better. So, you know, as fun as the bologna song is to sing, you really should not eat bologna. It's, if you know where it's coming from, it's pretty sad. All right. You always want to change the patient's mass to kilograms. In fact, in most clinics, I'm pretty sure people are measured now in kilograms because dosage is always in the metric unit. So we're just going to do practice going pounds to grams to kilograms. I can do it pounds straight to kilograms, but we're doing practice here. So we're going to humor me that if you keep using these four, you're going to get used to them and you're just going to know them. But put them on that piece, like make your own chart with our metric units and these conversions. And that way, just put it on your wall with your periodic table. And that way it's right there and you can do these. And if you're brand new to this factory label, do this page again and see if you've got it. And so kilo means 1,000 or 10 to the third. And now we bring the dosage in. So for every 1 kilogram, this is the gnome's weight. We're going to have 42 milligrams of the drug, which is the UBB. So you don't have to label it more than milligrams per kilogram, but it can help to make a note the kilograms is the gnome, which is what we started with. And now we're at UBB. And then just have to change that. Milli is 10 to negative 3. And you should get my answer. Oh, my answer is in milligrams. So my answer should be 0.060 grams. So to show two Sig Figs, something to talk about in the video, the zeros before the non-zero, zeros to the left of the non-zero are not significant. Zeros to the right, if there's a decimal of the non-zero, are significant. This has two Sig Figs. Or significant digits. A lot of teachers call them Sig Digs. All right. That's all I have unless somebody has a question. I'm going to stop recording.